there. And I must thank Srinivas Garu for accepting the invitation to give the webinar on the role of artificial intelligence in IT operations. And in this regard, I must thank Dr. Kameswara Garu, who is the person to utilize this webinar. And I must appreciate and I am thanking all the organizers for conducting these webinar series in this way. I must thank all the participants for showing your interest and a kind heart to cooperate such a kind of attending of these webinars or whatnot. Everything, whatever the activities we are conducting from Department of Computer Engineering, it is ECM department, KL University. I thank once again. You know that from this webinar onwards, we are facilitating all the features like YouTube live streaming is also there in this webinar. You know that earlier we already informed to you from June 1st onwards, from June 1st to 6th, we have a 1 week faculty development program on IoT and AI applications. And eminent speakers are attending and delivering. They're going to deliver deliberations on a wide variety of the concepts of AI and IoT. And that hands-on experience, hands-on is also included in that webinar. I am proud to say on behalf of Department of Computer Engineering, so far we have received 2,000 registrations across the India, not only the India, and a few reputed universities from USA, like universities from Dallas, Texas, and some universities in Malaysia has also sent their participation registrations. I must thank all once again, and I am really appreciating the organizers for great propagation of this FDP and all the activities across the India and abroad also. Definitely, I'm assuring you, even we have a chance to conduct such a kind of FDPs with a massive way. Even 2000, we don't mind. We can comfortably conduct these online faculty development programs like this or webinars like this in a grand way without any disturbance. Definitely, you can feel free to, because we have a YouTube live streaming, you can ask your queries at the same time, and the speakers can give the clarifications and all. Such a kind of facility is there. In this regard, after introduction of our today's speaker by Sridevi Madam, that Dayasagar can give some information. Now, I'm requesting Sridevi Garu, please introduce the speaker.
Thank you, sir. Thank you so much. It's my privilege to introduce our today's guest speaker, Mr. Sai Srinivas Jeedigunta. He is an IT leader with over 20 plus years of experience in managing large, global, and complex IT engagements for Fortune enterprises as pre-sales, engagement, and program delivery manager. Proven experience in establishing successful client partnerships, driving governance, growing engagements, building pipeline of new opportunities, partnering with executive leadership and cross-functional teams in driving strategic transformation and modernization initiatives, including cloud adoption and migrations, both private, public, and hybrid. Software-defined data center, infrastructure engineering, HCI, and engineered appliances, and AI and ML-powered IT operations solutions. He had worked with as an associate director, infrastructure consulting services, Trinas, program manager, cloud infrastructure and security, Infosys, Genpact, AVP, infrastructure, database and security services, DBA manager in GE Capital, lead applications DBA in Intech Group, senior Oracle DBA in Points of Private Limited, technical consultant, Anila Software Consulting Services Private Limited, technical executive from SDG International Limited. So now I welcome Mr. Sai Srinivas Jeedigunta to take over the session.
Thank you, Sridevi. Thank you. Thanks, everyone.
Srinivas Garu, thank you. Thank you so much. This is Dr. Sivan Prasad, Head of the Department, Computer Engineering. I am really happy to invite you for this webinar, and on behalf of department, I am thanking you for accepting our invitation even in a busy schedule. Once again, I must thank Dr. Kameshwara, who is the person to materialize this. Thank you, sir. Thank you, Srinivas garu. You carry on, please.
Yeah, thank you. Thank you so much, Shiva garu. Thank you so much for the opportunity. I must thank Kamesh also for giving me this opportunity to come and share my knowledge, my experience here with all of you. I always look forward for opportunities like this where where we can share our knowledge, learn from each other's experiences. This is one of my favorite part and one of my interests, and very excited for this opportunity and for being able to share my experience with all of you. And great to see the initiatives that you just mentioned about in terms of faculty development programs and bringing in industry experts and having them share their knowledge and best practices with the teams and kind of empowering the overall knowledge landscape within your institution. It's really amazing to hear that, sir.
Thank you, sir. Thank you.
My voice is coming across okay, right? Everybody able to hear me okay?
Yes, sir. It's perfect.
Awesome. Okay. All right.
Share your screen also, sir.
Okay, I can share my screen. That's my next question. Thank you.
Yes, sir.
Give me 1 second. Let me know once you can see my screen, right?
Yes, sir.
Okay. You can see my screen?
Yes, sir.
All right, perfect. Thank you.
Thank you.
So yeah, I'll just thanks Sridevi for actually running a very detailed intro about myself, about my profile and all. I'll just spend 2 minutes, giving you a crisp intro on my experience, and then we will straight away jump into the topic right after that. Yeah, I have over 20 plus years of experience in IT. I started way back in 1999. I and Kamesh are the school friends, actually. We studied together until 10th grade. And I started my career in 1999. I did some education and training at the beginning of my career. I used to do training programs for institutions like CMC and STG at the beginning of it. Then I did briefly some software development, and then I worked as a hands-on database administrator, for about 2-3 years. And after that, it's majority in terms of working as a program manager and leading the service delivery function. And over 15 plus years experience in terms of managing large size complex IT engagements for multiple Fortune businesses, like General Electric is one among them. Goldman Sachs is another one. There are a few other clients that I was associated with during my experience in terms of managing their infrastructure engagements. So that's really my experience is all about. I'm gonna turn my video off as I get into this topic. I don't want to kind of put any lags in the communication. And while I do that, if there are any quick questions, any quick expectations, or anything that you're expecting as an outcome of this session, I don't mind spending 5 minutes before we actually start on the topic. Sridevi, just in case if I lose sight on the chat, if there are any questions or anything, please feel free to stop me during the session.
Sure, sir. I'll follow you.
Okay, perfect. Thank you. All right. Okay, so let's get started. The topic for today's session is AIOps, which is artificial intelligence for IT operations. Most of you might already know what is IT operations all about, but I still want to give benefit to maybe a very little percentage of the audience who might not really have an understanding on what exactly the operations part of the IT is all about, right? So there is development teams who do the software development, and once the applications that we develop go live into the production, customers facing, basically where they start using the applications in real time. If there are any issues with those applications, if they encounter any trouble with the applications, then basically the teams that are responsible for managing the ongoing operations of the production environments, we refer to them as IT operations. Their primary responsibility lies around managing the availability and the performance of all the applications that are customer facing in reality. And they will have some sort of scope.
Srinivas, sir, sorry to disturb you. Have you shared your screen? That means we are getting only one slide only. I mean,
I'm still in the first slide. I haven't gone into the next topics. I'm just trying to give a quick brief about IT operations, and then we'll start into the presentation.
Okay, sir. Fine. No problem.
Yeah. So the IT operations teams basically are responsible for making sure that the production is available for the customers and it is running at an optimal performance. So it means that they are constantly monitoring the availability metrics and the performance metrics of all the production infrastructure around the clock, 24/7 across the globe in some cases, as complex the organization turns into, right? So you can refer to as simple as you're using an application in your mobile, or you go into a website, you're trying to fill a form to purchase some item, and you encounter a error saying that your transaction did not go through because of some HTTP error, because of some 404 error, whatever, right? So when you see that error, basically what happens is that the same error is captured as a ticket for the IT operations in the backend, who's gonna get a notification that one of the users got this problem, and they basically will start working towards it in terms of resolving the issue and bringing it back online. And if it's going to take a long time, obviously you go into the support center, you take the contact number, you call the help desk and say, hey, I was in your page of Amazon.com trying to buy something, or I'm in this website trying to buy something, and when I'm filling the form, I got an error that page timed out or something like that. Can you please look into this and help me with the problem? So help desk will take the call, and they will actually contact the IT operations in the backend, who are the subject matter experts that can understand the logs of the application, understand the logs of the network, understand the logs of the database, understand the logs of the storage, see what actually went wrong, resolve that issue, and then basically bring the application back online so that it's available for the customers. So that's the team that we're talking about. And this artificial intelligence, what sort of impact that it's going to create for those teams, right? Why is it even needed, first of all? What is the value of AI for those IT operations teams is really what our conversation is going to be for the remainder of this session today. Okay, so I'll move on. I tried to put together this material very quickly. I thought it will help us to stay on the topic and with a focused agenda, so that we can cover these topics, and it's easy from the flow standpoint, and it's easy from the consumption standpoint, which is why this PPT has some pictures, materials that I have taken from the publicly accessible content in the internet meant for educational purposes. It should not be very hard for you to find out what I'm talking about, but if there are any questions, any references or material that you need more, I'm happy to facilitate. So from the agenda standpoint, first we'll talk about, how has been the evaluation of IT operations has been, right? We will try to do some time travel here, go back to late 90s. How did the IT started, and what has happened from the transformation standpoint from that point till now? What are the challenges that teams are facing in the IT operations world? Then what is AIOps, right? What's the architecture of this AIOps solution is going to look like? With AIOps, how things operate, right? And what are the potential benefits that it's going to bring on board? I have put question and answers towards the end of the session, but like I said, feel free to stop me anytime during the conversations. I don't mind getting disturbed in between the flow. So, I'm very happy to address any questions if you have trouble understanding as we go through this topic. All right. Sridevi, so far good? No questions, right?
Yes, sir.
Okay, awesome. All right. So evolution of IT operations, right? I tried to put this in a graph. The x-axis talks about the number of monitoring events. The y-axis is talking about the number of monitoring tools, right? But let's look at the time scale. Look at 1990s, right? We used to have.
Sir, sorry to disturb you. Have you shared the PPT? I mean, any presentation?
You are able to see my screen, right, with the PPT? I can share this after the session if it's okay.
No, sir. Actually, here we are getting only somewhat of a small tree only.
Oh, really?
Yes, sir. That's what I'm asking.
Oops. So, okay, I'm so sorry. Give me 1 second. Stop share. Okay, I'm clicking on share, desktop, whiteboard, Microsoft PowerPoint, share. I'm so sorry for the inconvenience here. Just give me 1 second. Can you see now?
Yes, sir.
Yes, sir. Yes, sir.
All right. Perfect. Awesome. Very good. Okay. So, all right. So
Sir,
let's
can
go
we
back
go
to
with the slideshow?
Sure. Okay. Is it better
Yes.
now?
Yes, sir. Fine.
Okay. So, so from the evolution standpoint, right? In 1990s, we used to have client-server applications, right? You have a backend server which hosts the database, and there are terminals in the front end which host the application side of it, where there were transactions going on, and all those transactions go to the server, they recite the data there, and it sends the communication back with the approved workflows and stuff like that. Typical client-server applications used to exist in 1990s. Complexity wise, it's less because the limit of the reachability of the applications is usually within the enterprise. So monitoring wise, it is not really very complex because everything happens within an enterprise, easy to detect the issues, easy to understand the problem, easy to resolve the issues and stuff like that. So the number of monitoring tools on the y-axis, you can see it's less than 5, which means it's not like so many monitoring tools that are really required in order to monitor the production infrastructure, right? And then we moved on to 2000s, where internet applications have started to come into picture, where you have applications which are global in nature. There are people who are accessing the application from different parts of the world. Obviously, it means that you have to replicate your systems, distribute them across various locations. There is synchronization required. There is people talked about mirroring of applications, mirroring of data centers and stuff like that during these eras. So the complexity has increased. There are more number of servers, there are more number of applications, there are more number of nodes, and there are more number of peripherals. Obviously, you need more number of monitoring tools to be able to monitor this infrastructure. So the number of monitoring tools increased. And if you see the x-axis, your number of monitoring events also are increased because of that. So you look at the next generation, which is from 2010 onwards, the cloud generation has started, and 2015 onwards, now we are talking about containerization, right? Microservices adoption. The app infrastructure is more complex these days than anything else. There are purpose-built applications being created in the enterprises, right? So we are talking about going live pretty fast. We are talking about agility in the environments. There is a need for the business. They want to serve customers on one of the particular business use case, then application is going to be developed specific for that requirement. They're going to be hosted in the clouds, and the monitoring needs are changing because of that. Like you're now talking about IoT based applications. There are devices through which applications are being consumed. Some are being viewed using the peripherals like Apple Watches and stuff like that. Some are mobile based applications. So the landscape has increased significantly, and as the landscape is increasing, the requirements of monitoring these infrastructures, the requirements of monitoring this data flow, these data streams are also constantly increasing, and more number of monitoring tools means more number of events, right? I put 1 million here, right? This is assume that this is 1 million monitoring events on a monthly basis, right? And it's not true for every organization, but I'm talking about thinking about a complex organization, right? So imagine what it is like getting 1 million monitoring events in front of the screen, and you are going to deploy a team on 24/7 basis who is supposed to be responsible for looking into each of this event, looking into each of this, understand what sort of problem is happening, and do the corrective action, and then close this event. I think everybody is convinced by now that how complex it can get as the enterprise landscape gets more and more complex, introducing more and more applications, introducing more and more tools, right? So now you'll be able to understand that it is just impossible for humans to handle this by themselves. There has to be an intelligence built on top of it. There has to be a knowledge system built on top of this whole thing, which can help humans in facilitating those decisions, in faster resolutions of these issues, and help basically resolving them faster, right? If you buy my application, and if I tell you that it can take up to 10 days to resolve an issue, will you even pay me for my application, right? If you are buying a service, if you are subscribing to a service, then your bare minimum requirement these days is that I want the service to be 24/7 available, right? If a service breaks even for a second, then it's almost possible that we lost a customer these days, right? Because that's the level of competition that exists today. And the customer's expectations around issues being resolved so quickly is increasing day by day. So that kind of put a lot of pressure on the operations on the back end, right? So that's the use case. That's the problem statement for AI ops here, right? That so the component of AI is coming on board basically to help facilitate those decisions, to help provide context in this millions of events. What is the story that's going to come out of this, right? What is actually impacted? How quickly can I give the operations person sitting on the seat in the shift the right information so that the person can go and perform a right step in resolving that issue? That's really what the role of AI is in terms of IT operations. Okay. Are we looking at any questions so far?
No, sir. You can continue, sir.
All right, perfect. Thank you. Okay, so I have listed down some challenges here, right? In the current scenario, in the non-AI enabled world, right? What are the challenges going to look like? One, we talked about IT landscape increasing exponentially, right? Significant increase in the landscape, more applications, more monitoring tools, more softwares being introduced to, that are purpose-built in nature, that are focusing on particular aspect of the business services, the ERPs, the CRMs, the ITSMs, the content managements, an underlying database, network, storage. You imagine an enterprise, you're talking about IT landscape being significantly increasing from time to time, irrespective of the type of organization. And more applications means more monitoring tools, and more monitoring tools means more events. So today, as I said, there are millions of events to monitor, making it impossible for operations teams to cope up, right? The companies are hiring people from the markets to sit in front of the computers and monitor the screens for 24/7, and they are actually sitting and resolving the issues, and teams are not just able to cope up, with the heavy amount of volume of incidents that are coming in front of them. So what this results in is people become robots. They basically sit, they take it, they do the repeated tasks. Okay, this has failed, I take it, I resolve it. Again, the next one, it failed, I take it, I resolve it. Person coming into the shift starts with this and leaves the shift by dealing with the last type of alert. And finally, what exactly does it mean, right? This individual is not doing any innovative or any innovation, right? That's the most important problem. You hire the staff so that they innovate, they use their knowledge, they come up with ideas, and they help in enhancing the firms and improve the business and stuff like that. But if the individual is just only sitting and troubleshooting, then you can imagine that the whole concept of innovation is missing in there. So that's one of the top use case here for these problems, right? And the next important thing is poor customer experience. Imagine, your IT operations teams are sitting in a floor, right? Let's take an example, like let's take an example of a bank, right? I'm trying to open a Bank of America website, or my personal bank's website, basically through a web browser, and it is taking significant amount of time, and I'm getting a timeout error. The page is not getting loaded. So obviously I need to perform a critical transaction and the page is not working. I pick the phone call and I call the help desk. I said, guys, I'm having trouble in accessing your website. And imagine a help desk person who is most likely not an expert in any of the area, right? The help desk usually are the people who takes the call and route it to the correct department in terms of who needs to work on to resolve the issue by telling them that here is the issue that I just received in a phone call. That's usually the help desk, right? They facilitate in transmitting that case to the right team who can actually resolve the issue. So now the help desk person takes the phone call and he hears the problem of the customer stating that this person is having trouble in loading the page. The page is just taking time, longer time. It could be because of a numerous number of reasons. Sridevi, can you still hear me okay?
Yes, sir. Yes, sir. I can hear.
Okay, I just heard some sound from the back, so I didn't know what was it.
Not from our side.
Okay, all right. So, all right. So imagine the trouble that help desk person is going to face in getting the right people involved, right? An application running slow is a very, very common symptom. It's a very common problem. And it is very difficult to trace what segment of infrastructure is actually causing this problem. Is it the database? Is it the network? Is it the storage latency? Or is there something wrong with the computer itself, what the person is using to log in? These are all the various possible cases, right? So this help desk person doesn't know who should I call right now, right? Should I call the database expert? Should I call the network expert? So it's a guesswork, right? So they basically say, okay, you know what? Let me call everybody and just flash a message saying this application is running slow. So all these teams will start looking into their logs, their infrastructure logs, and see, is there any problem? So database team says, hey, I just looked at all my logs, everything is okay. Network team says, I just looked at all my logs and we are okay. And similarly, the storage teams and everybody, right? And finally, somebody says that, oh, you know what? One of the routers went down in the network and that's causing latency to some particular region. And this is probably the reason because of this. Imagine how much time it's going to take for the team to be able to come up with the root cause if we talk about the orchestration like this. And imagine what happens to the customer experience. Is it possible that the customer is still waiting to perform this transaction, sitting in front of the web page and doing a refresh? Absolutely not, right? And if the customer is just opening your website to open an account, you lost the business. And the amount of dollar impact you have depends upon what exactly is the size of the transaction that individual is trying to perform. And for a multinational businesses, for geographically dispersed businesses, imagine what this would mean from an impact standpoint, right? Which is why I said poor customer experience. It's a very simple sounded statement of poor customer experience, but ultimately this is the business, right? If customer is unhappy, you will not exist. It's as simple as that. And some interesting statistics that we keep hearing, when we interact and read materials around this and hear directly from the customers and stuff like that, right? In terms of the stories of IT operations, it's shocking that despite of heavy investments in bringing various softwares for monitoring purposes and improving the overall visibility of the IT environments, despite of all that investments, right? 25% of the issues are detected by the tools, and the rest 75% almost are detected and logged by users. Isn't this a severe embarrassment for the business? I'm hiring subject matter experts who understand technology to resolve the issues faster. I am buying softwares to monitor my environments and let me know the moment something goes wrong. Despite of this heavy investments that I made, both from human power, from a human resource standpoint and also from technology standpoint, it's roughly about 30% of the incidents being detected by the tools, and roughly about 65 to 70% are being noticed by the end users, direct customers who are calling us to the help desks and say, hey, you know what, I'm seeing this problem. Oh, and from there, you actually know that, yes, there is a problem. For some reason, the tool did not detect this, or for some reason, the people who are working on it thought that this is not an actionable event. They ignored it. There were human errors. So many reasons, but this is the story for it, right? This is the metric around it. And other important challenges, more than 40% of these incidents requires all hands on the deck, or a big war room kind of a setup to handle and resolve the issues. So when I say war room to handle, it's basically, you can say all of your experts are in a conference line and everybody is doing their part in resolving that issue. So in a million event situation, imagine what 40% would look like, and imagine what would that mean from managing incident standpoint in an organization. How much of staff in the call, how much of time is going on, just because of just because of the fact that there is no easy way to know where is the pinpointing issue as the enterprises continues to grow. That's really the crux of it, right? So those are the challenges. Any questions on the challenges before I move on to the next slide and talk about AIOps? Awesome.
As of now, no, nothing, sir. You can carry on.
Okay, and my voice is coming okay, right?
Yes, sir. Perfect. Perfect, sir.
Okay, thank you. All right, so AIOps, right? So the first 4 lines definition that you are seeing here is from Gartner. Anybody who goes to Google and type AIOps, this is the definition that you will get respond back with. And Gartner is the software research and advisory firm that has coined the term AIOps. I think, I don't remember the year, but maybe 2017 or 2018, where they said that AIOps basically is going to be the next big thing from IT operations standpoint, because we are seeing this as a big problem across every enterprise, and AIOps is the solution to a lot of these problems. Right, and from a definition standpoint, I'm not going to read that first 4 lines there. I'll try to give you the gist of it. It's basically a software platform. AIOps is going to be a software platform with 3 important, or rather 2 important abilities in it. Right, one is ability to support big data, and second is that has inbuilt machine learning in it, through which it can correlate, it can enrich, it can simplify, and it can automate, and it can help with better visualizations, right? Those are the requirements that that are defined for this product of AIOps, right? So the AIOps is a software platform with built-in machine learning algorithms and with the ability to support big data capability. That's really the simplest way to understand the definition of it. And if you're seeing the picture here, this is from the Gartner's picture, like I mentioned. This is the central circle is the platform here. And the fact that the term machine learning is coming into the picture, continuous learning becomes the key aspect of this, right? The data is fed into this software. It's going in an ongoing basis. It learns in terms of what are the remediations. It learns from what exactly is being done to resolve issue, and it'll continue to enrich itself. It continues to provide more and more value in an ongoing basis. That's where the power of machine learning come into the picture, right? So some of the features of this AIOps platform basically is mentioned here. It's a software platform. It has machine learning algorithms, supervised and unsupervised. It has big data capability. It has ability to ingest machine data, real-time and historical. Real-time is on an ongoing basis. It can take the raw machine data that's coming from various monitoring tools across the organization and get into this centralized platform of AIOps, right? On a real-time basis. At the same time, you can also take a historical data set and load it into this software and do some analysis on top of it, which is why I call both real-time and historical data. And when I say various IT sources, yes, you can get data from network monitors, you can get data from database monitoring software, you can get data from IoT devices, you can get data from CRMs and Salesforce, various kind of anything you name it, any application related things which can log data, you can get those data and ingest that into the centralized platform. So that's the ability that this software has, right? And it supports the infrastructure that is on-premise, which is in the local data centers. Some monitors probably are cloud-based, like CloudWatch of Amazon Web Services, where it constantly monitors the infrastructure that is hosted on the cloud. And even in a hybrid scenario, right? I have some infrastructure that lies in my data center, and there is some infrastructure that lies in the cloud, and I have monitoring softwares that are monitoring both of them. Now I get all the data of monitoring events ingested into my AIOps platform so that I can use it for my analysis, and I can draw the contests and help in resolving the issues faster and stuff like that, right? And this tool will have ability to automate, right? Like I said, when individuals are working on these issues and they take steps in resolving issues, and those steps basically can be scripted, they can be reused, the knowledge articles will be shared in the platform so that next time when the next analyst comes and tries to work on an issue, that analyst will be given the feedback that previously this person has worked on it, and here are the steps this individual has taken. And I think by running these steps, this issue will be resolved. Would you like to run this right now to resolve this issue? Won't you love it? Right? Wouldn't that increase the productivity of the staff that's on the ground, right? So that's really, that's really the crux of it, right? And that's the capability what this tool will bring in. And high-end visualizations, right? I will park on the high-end visualization aspect of it for the next slide, but for now you can just say that it's an ability to provide a deeper look into how my infrastructure is behaving, with an ability to look at every aspect of the infrastructure, right? Various dashboards, you can say, looking at the monitors, like health monitors kind of thing. And more importantly, ability to monitor a business process. Again, this I will talk about it in the next slide in terms of what is the meaning of ability to monitor a business process. Any questions so far?
No, sir.
Perfect.
Sir,
okay.
Srinivas sir,
Yeah.
how can we bring them these apps to student level to deliver in comfortable way, and how we can instruct the students to do a small projects in their level for better understanding of AIOps in IT operations, or maybe for better perspective of their job point of view. And it means you said it's a very demandable concept in future. Definitely, if you train the students in that line, definitely it may be useful. In that context, can you throw some light regarding of that?
Absolutely, sir. That's actually a great question. So you might be having various applications in the institution today, right? Maybe for your library management, for student access, students records management, various applications you must be having in the institution today that are hosted, right, within your local data centers and stuff like that. And I'm sure there is some level of monitoring on them today, right? That means when they go down, you will come to know about it, right? And somebody is working to resolve it, right? So that can be a great opportunity for for students to kind of do a small prototype level assignments on it, right? What sort of issues are happening, and when an issue is happening, what are the patterns around it, right? They can use that data set. It is going to be small because it will not be probably as complex as a real multinational or geographically dispersed commercial business and stuff like that. But this small data set would enable them to be able to think big and apply the similar kind of logic as for a larger enterprises also, right?
Yes, sir.
So yeah, so I think that's a great use case, and definitely they'll get some sort of exposure in terms of taking that data sets and understand what's causing this issue. They probably can take some of those incidents that have happened in the past, right, and come up with a pattern-based analytics in terms of what started, how did the symptoms start, and finally what has happened, and what was done to correct it, and apply that learning on the model so that you can tackle the issue when the symptoms start itself instead of waiting for the actual thing to broke.
Yeah. Just like a case studies.
Correct. Yeah.
Right, sir. Fine.
Okay. All right. So, okay. So this is the pictorial representation of what I just mentioned about AIOps capability, right? Look at the left side here. You can do the historic data ingestion or the real-time streaming data. Vendor agnostic. Doesn't matter who's the vendor of this monitoring tools, right? You maybe, let's say in my institution, I have few Oracle monitoring tools. I have few Microsoft monitoring tools. I have few Red Hat monitoring tools. I have few other vendors monitoring tools. And then this AIOps will still be in a position to get all this different vendor-based, basically, alert raw machine data into the system, and be able to consume the data in order to drive the analysis, in order to do anomaly detection, performance analysis, correlation, and contextualization, right? So that's the pictorial representation of what the features what we have saw in the previous slide, right? I also want to spend a little bit time in terms of the outer curve here. If you see, as the events come here, the monitoring teams are observing it. And once they observe it, the ITSM framework kicks in, right? ITSM is basically what happens when an incident happens, when something is broken in an organization, right? You want a track of it. You want to know at some point later in time, who has taken that issue, what was done to resolve that issue, and what time the issue is started, what time the issue is closed. Usually this all is tracked in the ITSM software. Examples are ServiceNow, BMC Remedy. Most likely that every organization will have one of these, this ITSM softwares, which they use in order to track the overall service management aspect of it. And this data within the service management tools is used to identify what are my top opportunities to automate so that I can save productivity, I can improve productivity, I can resolve issues faster, right? Which is the automation act on it, right? So observe, engage, and act is basically the IT operations main goals that is basically leveraging the capability of AIOps. Okay, so that's the architectural view of this platform. And I want to spend couple of minutes in terms of machine learning here. Again, most of you would know this is a computer science concept. You probably are better experts than me, but I'll still highlight very broadly in terms of three categories of machine learning. There are three categories of algorithms broadly. One is supervised learning, second is unsupervised learning, and third is the reinforced learning, right? If the data set that I'm giving to the system has labeled data in it, then that becomes supervised learning. Example, I can take the cricket statistics. I can say that the name of the cricketer, the number of matches played, and number of scores made, number of runs made, and number of wickets taken. Let's consider that that's a data set, right? And again, please feel free to stop me if you're not following. I'm just thinking something real time here as I'm talking. So, name of the cricketer, number of matches, number of scores, and number of wickets, right? If I'm giving this data, and if I say that looking at the number of matches played and looking at the number of runs made and comparing it with the number of wickets made, I want you to tell me whether this cricketer is a bowler or a batsman, right? So in the data set that I've given to the machine, it does not have the bowler and batsman category, but it has the number of runs made, right? So when the data doesn't have the labels in it that I'm asking machine to detect, basically that becomes a unsupervised because there's no labels for me to be able to identify that. But let's say if I take an example that, like, I'm showing 100 apples to the system, one apple on a table, one apple on a chair, one apple on a TV, one apple on fridge and stuff like that. I'm showing 100 different type of apples and 100 different types of oranges, and I'm telling them that this is apple, this is apple, this is apple, this is orange, 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 and finally I show a different orange picture and say, hey, what is this, right? It says it's orange. It's basically using its knowledge that it has acquired based on the pictures it has seen, the data labels that it has seen, and it's guessing the future versions, basically saying that, okay, this is the object based on what you taught me so far, right? So that becomes a supervised learning. And these are the examples what I could recollect that I have read from the past, so I hope it helped in terms of understanding these algorithms a little bit. But again, when you come into the AIOps platform, the advantage is that it's important to know how these algorithms work, but they're already inbuilt in this platform. They're already in there. You need to know which algorithm do I pick for, depending upon the type of data set that you are selecting, right? And the third category is the reinforced learning, which is basically a feedback-based model. You showed some systems and you basically say, now can you guess this picture? It says, no, I cannot guess this. Is it I show a picture of the dog. It says, hey, is it a cat? And then I say, no, it's a dog. Okay, so I'm learning that it's a dog, right? Next time I show a different picture and say, is it a dog? It says, yes, based on the picture that you show me in the last, yes, it's a dog, right? It's basically taking your feedback and it incorporates it and it learns it. One example that comes to my mind at this time is Google Photos, right? If you use Google Photos, sometimes when you log in, it says, hey, is this picture equal to this picture, right? Some picture from the past converted to some picture to future. It compares both the things and say, hey, are these two people the same, right? So, and then you say, yeah, yes or no. And if you say yes, it groups it accordingly. And then when you open the Google Photos and say, search for this person, right? Show me pictures of all this person. It actually brings up all those pictures. So it's a good example of reinforced learning because it's taking your feedback, it's learning from it, and it's applying it on top of the data set, right? So it exists everywhere right now. It's all around us. Every software service that we are using, every application that we are using has already been implemented with the levels of AI in it. And you're already reaping the benefits of the AI in a real world right now. What I just gave you is few of those examples, but you can see tons of those examples. When you go to your Amazon Prime, you watch a movie, and at the end of the movie, it says, hey, you know what? I think you like this movie, right? it's trying to, it's asking you, do you like this movie that you just watched? You say yes. Then immediately you get some recommendation saying that, okay, I think you will like this movie, this movie, this movie also, right? How is it doing it? It's basically taking the data labels like, genres, it's taking actors, and it's trying to compare it with 2 or 3 movies that you saw. It's comparing the likes, and it's saying, okay, most likely this person likes this stars, this actor's movies. I think you will like this movie. And after you watch the movie, it's again going to ask you saying, do you like the movie? You say no. Then it basically makes another subset out of it saying that, okay, he liked this, but this person did not like this. And it basically compares again this data set, and it builds a model internally so that it's getting customized for you as you use it more and more. And that's the learning, continuous learning that I talked about, right? It's not just about one time. The more the data, the more the benefits. That's the bottom line of machine learning. With that, I'll stop there. I hope you were able to understand the bottom line of it. It is significantly useful in the IT operations world because it helps in terms of noise reduction, right? I'll give you a simple example. I have I set up a threshold that if my drive crosses 70%, I want you to send me. So it crossed 70%, it sends me an alert. Another 5 minutes, it sends another alert. Another 5 minutes, it sends another alert. Another 5 minutes, you keep getting these alerts every 5-minute frequency until you actually go and resolve it, right? But in real world, if I have a 1 GB hard disk, let's say, if it is 70% full, you're talking about 700 MB full. You still have 300 MB, right? If your usage is not 300 MB, you really don't have to worry about it, right? It took 6 months for you to fill 700 MB. That means it's probably going to take another 3 months plus for you to fill 300 MB. I don't really have to send you the alert right now because I know how you're using it. That aspect of I know is missing until the AI has come into the picture, right? It was blindly sending me alerts, rules, right? Based on the rules, I just send you alerts, millions of alerts. Are people doing anything to resolve it? No. You know that I still have 300 MB. I have more than 3 months more to buy a disk. So you're not doing anything, but alerts are keep on coming in. With AI coming in, that alerts will reduce. That's where these algorithms come into the picture. The 2D standard 2D deviation algorithms and your K-neighbor algorithms. All these algorithms will help in terms of fine tuning this, noise reductions, enrichments, and correlations and stuff like that. Okay, and this is how the orchestration process is going to look like with AI apps, right? Okay, so I think we are on top of the hour right now. Timing wise, probably it'll take another 15-20 minutes. Is it okay if we extend?
Yes, sir. Another 15 minutes we can take, sir.
Okay, all right. Okay. All right. So this is the learning that I was talking about. This is the orchestration process with AI ops coming into the picture, assuming that there is an issue that has happened. Let's say that I have a business process, right? Let's say I'm taking KLC as an example here. I have a library application, right? Through which students log in, they identify the book that they like to rent, and they place an order, right? And once the order is confirmed, they basically go to the library and they pick it up. And once they return it, they will update the system, and system updates it. Let's say that's the behavior of this application. And let's say this application has one database in it, sitting in a database server. It has an application that is written using a software, and that is installed in an application server. And the database is in a Linux operating system. So Linux operating system will have file systems. And there are 4 or 5 file systems at the operating system level, which has all the data pertaining to those file systems sitting in there, right? And that's my setup, right? We will not make it more complex than that. Now, the thing is, let's say that there is a malicious user who logs into the system and usually, tries putting an order for like 100 different books order in one shot, right? And that's putting so much of load in the application. And whenever that happens, the system is not able to process that 100 records data at one single point in time. And it's usually basically timing out at the database level because the hardware is not designed to take that level of complexity. And that's failing the system, right? Now, every time that happens, the database is going down. Now, the help desk detects it, whoever is monitoring it, and that person calls the database administrator. The database administrator has to log in, has to go into the server, start the database, and basically, resolve the issue, right? Start the database and do a recycling of all the services, make sure that everything is checked, and then, start it. So this is what is happening, right? So now, in a situation like this, basically, if I can understand that, okay, this person has logged in, right? And there is a request been put in for 100 different servers, right? What would you like to do in the real world? You probably would like to define a policy where if this user comes in, you want to kick the user out. One of the remediation, right? Or you basically want to redesign in such a way that where I want to limit the number of books orders that it can be applied as far as this thing is concerned, right? As far as an order is concerned. So these are the various steps, right? That can happen in terms of remediation of the issue. And that's one of the example of continuous learning that I was talking about. So when you get an alert into the system, you correlate those alerts, right? You enrich that alerts and provide a deeper visualization of a business process, right? Imagine without AIOps, a help desk person sit in front of a computer where there are tons of alerts line by line listed in front of that individual. And with AIOps, I have a system in front of me where I can see my library as an application in a circle, showing me the green, either in green color or yellow color or red color. And I click on that library, it shows me the three components, a database in a circle, the network in a circle, and an application in a circle with, again, green, red, and yellow, right? Green means all okay. Yellow means some minor issues. Red means there is an outage, right? And let's say in a screen where all my components are green, suddenly something changes to amber because there was an alert that has come up and that's causing this issue. And if the help desk person has this level of visualization, has this level of view on the system, wouldn't that help in terms of resolving that issue faster? Imagine the earlier scenario example, what I just said, like, a person calling help desk saying my application is running slow, right? And the person has no visualization in front of him, right? That is, the help desk person doesn't know, is it network, is it database, is it application? I don't know what you're talking about. Now apply the same thing here. My platform is showing me the whole business process itself as a view, and I can double click on it. I can see that all three are looking green. And when the individual called me that my application is running slow, I can see that my network circle is actually amber. Now do I know who to call? And now I can directly call the network team, and network team will come and resolve the issue. That becomes green. It's telling me that, okay, the issue is resolved, which means the end user's issue is definitely resolved. I can confirm over the call saying that, sir, looks like your issue is resolved right now. Can you go back and take a look at it? Imagine this experience comparing with the earlier experience, what I talked about, comparing with the earlier experience where, oh my God, a major application is down. I need all my experts into one single call. Everybody's looking into their systems. We don't even know what they're checking. We don't even know whether they resolve the issue because there is no green, yellow, amber, red status. No clarity versus this AIOps platform, which is helping me in terms of doing this, right? And every time when I have something like this, all I need to do is I just have to restart it. So let me automate it. And let me make it an knowledge article around it so that next time, person doesn't even have to remember the steps to restart. They just have to go and run the script and the issue is resolved, right? That's the continuous learning, continuous enrichment, collaboration. That's the power of what this platform is going to bring, right? So potential benefits, like I said, noise reduction is one of the biggest one. End-to-end visualization, we just talked about it. The overall business process monitoring capability is what will be enabled using this platform. MTTD improved, which is mean time to detection is significantly going to improve because, like, again, I said, compare the two examples, right? Having nothing in front of you, receiving a call, trying to find out what happened wrong versus you have a complete business process view itself sitting in front of you and you can easily detect where the problem is. And as the knowledge articles continue to improve, your ability to respond is significantly improved, which means your MTTR is improving. Your teams are resolving issues faster. They have no more alerts in the system. So now what are they going to do? They're going to innovate. They're going to sit. They're going to be more productive. They will bring in more ideations and they will think about what can be done to improve the business and drive more value into it, right? obviously there's going to be more automation. That's an underlying hidden value add out of this whole thing, right? And continuous service improvements. So that's the potential benefits basically using this platform, and using this AIOps platform. And again, some examples of AIOps platforms that I can give you are Splunk is one among them, MoogSoft is one among them. Almost every monitoring software and almost every ITSM software that you can think of these days is redesigning or have already redesigned to bring in the AIOps capability into them. Okay, so but whoever wants to pursue a little bit more knowledge on this, please feel free. I strongly recommend searching for the AIOps software like Splunk, MoogSoft, and ServiceNow, and go into the softwares. You will be able to easily correlate to what we just discussed during this call today when you look at their videos and demos and YouTubes and stuff like that. Okay, so with that, I'll take a pause here for any questions, because that concludes what I wanted to discuss today in the call.
Sir, we have few questions.
Okay.
There is a question in question and answer section. I think you also can visible for that. And one attendee also want to raise the question. I'll enable the mic for her so that she can ask the question.
Sure.
Revati ma'am. Revati ma'am.
Yes, madam.
Now, yes, ma'am, you can ask the question.
Yes, sir. Sir, good morning,
Please,
sir.
go ahead. Good morning.
Sir, I have a question. Sir, I'm working in the area of atmospheric sciences. Here we have many devices for temperature data, sir. Suppose IMD Machilipatnam is having one set of device, and IMD in another place is having another set of device. Like that, we have some 4 or 5 devices which are having where the temperature data is collected. Now the problem is all these data cannot be correlated. Can we use this AIOps to correlate all this data irrespective of the measurements taken, irrespective of the flaws in the measurement or accuracies in the data?
That's I think that's one of the greatest example for the data sets, right? You have locations, and location wise you have devices which is capturing the atmospheric conditions, right? The temperatures, right?
Yes.
So in order to drive the patterns, what is the pattern of the temperature behaviors and stuff like that? Yeah, why not? I think you can take that data set, label them accordingly, right? Maybe the location is a label, and you can filter that basing on the location, and then you can do analysis on the data sets. But I mean, there are so many examples that are flying in my mind right now as I'm talking about it. Right, it could be in the lines of how is the temperature varying for the different days in a month or different months in a year, and what is the pattern compared to last year's? On the same day, what was the temperature 5 years back? If you have that size of data, right?
Yes, sir. Yes, sir. Actually, this is the DST project. When I went to DST reviews, one project came up with this idea that we have a lot of data in all the IMD centers, but now the question is, can we correlate this data, the temperature data, the humidity data, and can we come up with an accurate data which we can support for a software for analyzing the atmospheric conditions, the temperature, heat wave conditions like that?
My short answer to that is definitely yes, madam. There is no doubt about it. I think from the data wise, the problem wise, it is definitely yes, you can, but you need to look at the model, adjust it basically to make sure that you have all the data that you need to be able to predict what you wanted.
Well, my question is, normally AI and machine learning, what are all these algorithms are there? They are not for prediction. They are for automation. But how come prediction can be helpful by using these things?
No. They're not only for automation. They're also for prediction, right? Pattern detection, to be more precise, is one of the feature of this platform, right? And you have algorithms with which you can predict also. So it is not meant only for automation. It is about knowing something in advance is also the most important feature of this AIOps, right? Early detection is an important example. You don't necessarily wait for something to be completely broken. If you relate to the example of what I just told you, That instead of waiting for something to be broken, I want it to be able to predict that, okay, this user logged in, you are most likely going to have this system down, right? Look at that example. So it is for prediction also, and the algorithms will help in terms of prediction as well.
Thank you, sir. Thank you very much, sir.
Yeah, yes, sir. One more query, sir, from my side. Regarding of this artificial intelligence features to differentiate the situations like supervised observations and unsupervised observations. You explained beautifully the two examples, very popular examples like that. As far as unsupervised observations concerned, a particular in a cricket scenario, a particular batsman or maybe a particular cricketer, maybe we don't know the name and fame of that cricketer. Based on his performance, how he is doing well in a batting point of view or bowling point of view, how many wickets he has taken, how many runs he has done. Based on all these things, the artificial intelligence, this AI ops can differentiate such a particular batsman and identify such a cricketer is a batsman or a bowler. So that we can predict based on that. And similarly, one more example you can say, explained about supervised observations like apples. One apple is on the table, one apple is on the TV, like that. Based on the observations, we can identify such object with apple like that. So to differentiate such a kind of supervision and unsupervised observations, what basically the parameters are taken into the consideration to decide it is a prediction point of view?
Depending upon the data set, what you're trying to identify or what you want machine to identify, is it already been provided in it in a form of a label or a feature? Yeah. Or is it something that you wanted to learn it and then you want to basically guess from it because it doesn't exist in the data today?
Yeah. What I'm trying to say that to observe such a scenarios like that, how much time will it take to decide? It means instead of timing, certain parameters help us to decide a particular thing is this. Perfectly, this is. For a 100% prediction point of view, is there any a solid observations or parameters or a threshold point is there to identify?
No, unfortunately not. Not that I can think of. In based on the best of my knowledge, this is an exercise that is gonna be time consuming. It is gonna be, like I said, your start can be very quick, right? Okay. You can probably take 10 records and have the system start predicting based on it, have the system start analysis based on that. But you can never say that it is 100%, right? Because it needs more and more data, it needs more timescale based versions, and you have to constantly monitor and mature it also, right? So it's not like one time you plug it in and you forget it and expect it to work perfectly all the time.
Correct, sir. Correct. What you said in probability theory and detection of the images and all, we are using various kinds of signal processing algorithms. And it means in uncertainty and certainty examples are also, we are taking so many kind of the parameters. So usually the sun is rising in the east and it is downing in the west like that. In particular day, the sun is going to rise in the west and downing in the east like that. Somebody says to confirm that, and we have to use a particular algorithms very quickly to identify the scenario. Is it correct or false like that? Such a same kind of the situations are there in the artificial intelligence, AI ops algorithms like that. I'm asking. That's only.
Yeah, I think based on my experience so far with this is purely data driven. I think that you're right. Maybe there is a significant amount of processing that's involved if the question is too simple for a human to answer, right? That's a great example what you quoted. Yeah. This goes by the model detection.
Yeah. Thank you, sir. Thank you.
Yeah.
So there is one more question. Hello.
Yeah, please go ahead.
Yeah. AI operations develops what sorts of applications or services presently? Can we rely on machine learning models for applications like bioinformatics, biomedical use, where accuracy is the prime importance?
Yeah. No, I think that's another good question. So like I said in the beginning of the call, when I talk about AI ops, this is AI on top of operations fields, right? In the IT operations area. And I also defined what do I mean by IT operations, right? This is a team that's predominantly monitoring the infrastructure around the clock, helping in understanding basically where the issues are and helping in resolving those issues faster and making sure that the application is back available quickly and performance is to the optimal levels, right? But answer to your question, AI in general is applicable to all the fields across data sets, across various things. You have programming languages like Pythons and various other programming languages, which has this algorithmic ability to be able to bring on board and take a data set and you process it and you execute it. It doesn't fall into the AI ops category because it's not the operational work or operations related data that you're trying to process. It's outside the scope of AI ops, but basically, yes, it is in the scope of AI in general.
Thank you, sir. One more participant want to ask the question. Amar Babu, sir. You can unmute yourself, sir. Amar Babu, sir. Amar Babu, sir. He want to ask the question, but he's unable to speak, I think so.
Okay.
Amar Babu, sir, are you there? Sir, unmute yourself and ask the question, sir.
Amar Babu is the head of the Department of Electronics and Communication Engineering, Creative College, nearby Vijayawada.
Okay, sir.
Is there, sir? Madam?
He's there, sir, but he raised the hand, but he's unable to speak, I think so.
Okay.
Can you mention, please, some AI ops open source tools that can be included in our curriculum, which are very simple, which can be applied, which we can use for designing of simple applications, AI ops tools?
Yes, that's a good question.
Where our students can have some hands-on experience by seeing some videos, so on and so forth. That stuff, can you provide us?
Yeah. In terms of the functionality of the tools, I would suggest first YouTube. In terms of you can take any of the video, any of the topics like MuleSoft as a tool, for example, Splunk as a tool. Depending upon the usage, what I have learned is that these tools usually are basically priced based on the amount of volumes of data. And if you don't expect to load so much of data to begin with, there are free versions of the softwares available that you can take the trial versions and you can use it for your lab purposes. Splunk is available for lab that I know of. And I think you can try MuleSoft also as a trial versions. And there are various other softwares. ELK, Elastic is another tool that you can use. And I believe that's an open source that you can use to basically, try hands-on.
Yeah, thank you.
Right, sir. Thank you very much, Srinivas Garu. Really, your speech, your webinar today gives a lot of enthusiasm. It creates a lot of enthusiasm to go for AI ops. Definitely, we'll go through that, and according to your information, what you have given, we'll work out, and definitely this speech, this talk gives a lot of benefit for us. Thank you.
Thank you so much, sir. Thanks again for the opportunity.
Thank you.
I hope the session is useful and helpful. Thank you.
Yes, sir. Thank you. Thank you so much, sir. Once again, thank you all the participants, and we are expecting the same encouragement with our FDP coming soon from June 1st onwards.
Yeah. So all the participants, please make sure that, and please be convenient to attend for this FDP. Those are registered, and the last date for registration is up to tomorrow, 31st May. You can register. And so far we have received 2,000 registrations so far. Not only across India but abroad. Few universities from abroad is also registering participants from abroad universities. I must thank and really I'm appreciating our organizers for great propagation of this particular FDP and features for this, as we have a YouTube live streaming for this FDP. Thank you one and all. Please be ready for that.
Thank you, sir. Thank you so much.
Thank you, madam.
Thank you, sir.